Very good morning, friends. Today's subject of discussion is catalysis. What is catalyst? Catalysts are the substances which are used in the reaction to hasten up the reaction process. That is, it increases the rate of the reaction at which a chemical system approach equilibrium without even being consumed substantially. Catalyst beauty is that it hastens up the reaction process without involving in the reaction. It is something like your teacher. A teacher hastens up the learning process of the student without involving in the learning system. He only guides the students. Catalyst, it only accelerates the rate of reaction, that is it affects the kinetics of the reaction. It do not affect either thermodynamics or the equilibrium composition of the reaction. The catalyst acts with reactants to and hastens up the reactions between the reactants. How is it done? How it is accompanied? Let us look into the mechanism of catalysis. We know that the reactants and the starting material react, and during the reaction the collision of the reactants occurs, and when the collision occurs with sufficient energy, then bonding is formed and the new product is formed. The energy with which it collides with each other is called as energy of activation. Every reaction has an energy of activation, and that differs from reaction to reaction. A plus B, when it reacts, they collide with each other, and if I write the energy against the progress of the reaction, the energy on the y-axis and the progress of the reaction on the x-axis, when they collide, the energy goes very high and it moves to the highest, and at that position the bond breakage and bond making takes place, and when bond making takes place the new product is formed. The energy of the product is lesser than the reactants. That's where the reaction conversion has occurred. Every reaction is characterized by the energy of activation, which is the rate determining step for the reaction. If at all I use the catalyst, we need also the delta H, that is the energy to be supplied for the reaction to occur. Delta G, it gives the energy of freedom. Delta G, but it do not affect any of these character factors like delta G, delta H, delta S, and so on and so forth. But the catalyst affects this energy of activation. When I use a catalyst, this is a normal energy diagram for uncatalyzed reaction. If at all I use a catalyst, The energy of activation EA has got reduced to EA dash. Means it when it has got reduced, the energy with which it should collide will be less. That's why more reaction can occur because less energy required, and thus large amount of conversion occurs. That's why it hastens up the reaction process. It is this is what occurs in the catalysis. In the presence of the catalyst, the energy of activation is reduced. That's why rate of reaction increases. The catalysts can be classified broadly into homogeneous catalysts, biocatalysts, and heterogeneous catalysts. Homogeneous catalysts are of majorly two types: acid-base catalysts and transition metal catalysts. The biocatalysts are the catalysts which are activated by enzymes or immobilized enzymes. Heterogeneous catalysts are of two varieties: bulk catalyst and supported catalysts. Supported catalysts are supported metals, supported metal carbides, supported metal nitrides, metal oxides, and metal sulfides, respectively. What are these? On what basis these catalysts are classified? Let us look into it. Homogeneous catalyst is a single phase catalysis reaction. Means the catalyst, the reactants are in the same phase, typically in the liquid phase. This homogeneous catalysis occurs generally at lower temperature, but as the catalyst has got dissolved in the solvent system, the separation of this catalyst after the completion of the reaction is a challenge and also a tricky process. In heterogeneous catalysis, the catalyst and the reactants are in different phases. The catalyst may be in solid phase and the reactants may be in liquid phase. The catalyst may be in solid phase or the reactant may be in gas and liquid phase, and so on and so forth. When compared with homogeneous catalysis, heterogeneous catalysis requires higher temperature for the reaction to complete. Separation is easy, but because they are in different phase, just by filtration it can be separated. But however, the optimization of the process is little challenging. Heterogeneous catalysts are generally amorphous in nature with high surface area support. This high surface area support may be alumina, silica, or activated carbon, etc. These have hundreds of meter squares of surface area per gram of the substance. Or on this surface area, the transitional metals can be impregnated. The transition metals like platinum, palladium, nickel, iron, ruthenium, copper, and so on and so forth. They can be typically in the pellet form or they can be in the form of monoliths. The heterogeneous catalysts are most widely used in the class of catalysts, but least understood. They're highly used because of its economicity. Not only economical, they're highly stable, and their separation is also equally easy. And they can catalyze varieties of reactions. That is the versatility of heterogeneous catalysis. Their versatility, stability, and economical workup makes it the choice for the reactions. How these catalysts work? The heterogeneous catalysts can absorb or can adsorb on the metal surface. For example, hydrogen is the reactant which gets adsorbed onto the palladium. Palladium is the catalyst. And this adsorption is the surface process. Or the hydrogen can absorb onto the palladium, and the reaction occurs to give palladium hydride, and it is the bulk process. You see here, there is an interaction in adsorption on the surface of the catalyst. Here, it is not on the surface, it is all over the catalyst, the reaction has occurred. That's the difference between absorption and adsorption. Absorption is a bulk process, whereas adsorption is the surface process. The adsorption can be of physical nature. If it is of physical nature, it is classified as physisorption or named as physisorption. This is a type of adsorption in which there is van der Waals type of interaction between the catalyst and the reactants. As this is only a van der Waals type of interaction, the energy of the attraction is very less. And as the adsorption itself is a surface phenomena, it gets adsorbed over the surface of the catalyst. The energy of adsorption lies between 5 to 10 kilojoules per mole, easily broken. Another beauty of this physisorption is that many layers of molecule can adsorb on a single layer of the catalyst, like we have seen over here, layer by layer the hydrogens or the reactant can get adsorbed onto the catalyst. Chemisorption, as the name indicates, it has the chemical bonding in which there is a bonding, chemical bonding. This bonding has a better energy than that of physisorption. During the chemisorption, the whole molecule can adsorb or chemisorb as a whole molecule in intact form, or the bond may dissociate and it can form the bonding with the layer of the catalyst. This has a higher energy than that of physisorption, which will be around 30 to 70 kilojoules per molecule, per mole of molecule, and for atoms it will be 100 to 400 kilojoules per mole. Catalyst can be an unsupported catalyst. The unsupported catalysts are having large surface area. The finely divided catalyst can have large surface area. They are very active. They do not require any dispersion of the catalyst over the area of other support. They don't require support. The iron catalyst used for the production of ammonia in the Haber process is an example of unsupported catalyst. The supported catalyst requires a high surface area, and that support of the support, and this catalyst disperse over this surface area of support. That's why they are called as supported catalysts. This support what we use, it increases the surface area of the catalyst. In unsupported catalyst, this is not required, as it itself has larger surface area. This support which we use for supporting the catalyst, for increasing the surface area of the catalyst by dispersion across the support, can also act as a secondary catalyst, or it can act as a co-catalyst. That's why it is a promoter of reaction. It hastens up the catalytic process. And when it is in the free area, when it is heated, the sintering, they combine together to form a mass. But when it is supported over or dispersed over the supported material, they get dispersed, and that's why they have a larger surface area, and that's why reaction can takes place more faster and more easily. Now you can appreciate the role of support to the catalyst. Catalyst is like guru. The support for this catalyst is guru ka guru. गुरु को भी एक गुरु रहता है, वैसे ही सपोर्टेड कैटलिस्ट और लाइक गुरु का गुरु. Heterogeneous catalysis occurs in this manner. One of the examples is ethene reacts with hydrogen gas in the presence of nickel catalyst. Nickel in the finely divided form, that we call it as Rani nickel. It gives ethane. This nickel catalyst plays a vital role. Without the catalyst, how much ever time I react with hydrogen, reaction do not occur at all. But in the presence of nickel, the reaction occurs very rapidly. The nickel has a large surface area in its finely divided form. The ethene molecule pi electrons, pi bond breaks, and that forms the bond with the surface of the nickel. and the hydrogen molecule, the reactant, gets adsorbed onto the catalytic surface, and the hydrogen bond breaks during the process. The adsorption of ethene and adsorption of hydrogen has occurred, and as they occur nearer, the bond can be formed between this broken hydrogen with that of the carbon of the ethene, which has also got adsorbed. Now they have become neighbors. That's why interaction can occur. When the interaction occurs, the bond between the carbon and hydrogen takes place, and the bond between the adsorption between the hydrogen atom and the catalyst gets weakened up, and the similar reaction occur between the second hydrogen atom with this second carbon, and the after the hydrogen ethane is formed that leaves the surface. When it leaves the surface, that surface area is weakened for another ethylene molecule, and the process occurs. That's why nickel acts as an efficient catalyst. This is the mechanism behind the any heterogeneous catalysis. The supported catalysts are generally the highly dispersed metal and metal oxides, like silicon dioxide. There are various types of supported catalysts. One of them is ZSM5. ZSM5 is a support on which the paraxylene gets dispersed. The paraffins can get dispersed over zeolite support. Why zeolite? This Y zeolite or ZSM5 are widely used solid supports which disperses the reactant or the catalyst across it, and that's why it increases the surface area. When the surface area is increased, more chances of reaction with the reactant. What is this ZSM5 catalyst? It is the abbreviated form of zeolite Scoony mobile number 5. This was first synthesized by Mobile Company in the year 1972, and this has replaced many homogeneous catalysts, and this has a versatile utility in petrochemical processes. ZSM5 catalysts are available in two forms, with the pores of the with a diameter size of 5.6 angstrom unit and with a diameter of 5.4 angstrom units. Zeolite 5 is a diameter of around 7.4 angstrom units. ZSM 5 or zeolite Y have profound use in petroleum industry for the conversion of hydrocarbons. ZSM 5 zeolite is a highly porous alumina silicate. It is made up of alumina and silica with a high silica aluminum ratio.